Hi, my name is Alexander and I'm a software engineer with WhatsApp. I've been with WhatsApp for a little bit over 6.5 years now, and I've worked in the areas of infrastructure, payments, and more recently I'm working on privacy. Today we'll talk about how we build private products at WhatsApp. Here's an overview of our agenda. We'll talk a little bit about what WhatsApp is and how we think of privacy. Later we'll dive into two concrete product use cases, which are end-to-end encrypted backups and privacy tokens. In the end, we'll discuss security. WhatsApp is a leader in private messaging. We have over 2 billion active users and help deliver over 100 billion messages a day. WhatsApp is run as an independent unit within Meta, and privacy is at the core of our product. WhatsApp is available across multiple surfaces, such as Android, iOS, web, desktop, iOS, and Windows. Our mission is to connect the world privately. So let's talk a little bit about our tech stack. On the infrastructure, we use Erlang, that is for kind of the backend systems. There's a lot of cool technology that we built in Erlang to handle our scale. We won't dive into that here, but if you're interested in that, definitely go look it up online. On the client side, we use most of the native languages like Java, Objective-C, Swift, JavaScript, C, and some Rust. This list is not comprehensive though. For example, we're exploring using Kotlin on the clients as well. Here are some recent products that we've launched. One of them is multi-device, which enables you to use WhatsApp without having your phone connected all the time. Then we launched payments, disappearing messages, end-to-end encrypted backups, as well as a few business messaging solutions. One core design principle at WhatsApp is that it's very client-centric architecture. We have this expression internally, the client is a server. What that really means is that the client does a lot of the heavy lifting. That's where the data is stored in the long term. And the server acts as a facilitator for the clients. In general, we don't trust the server, especially when it comes to privacy and security guarantees. And we'll talk a little bit more about that later. Let's dive a little bit deeper into how WhatsApp thinks of privacy. So for many products, privacy is kind of just another requirement that you need to have. But for WhatsApp, really, we see it as a key product feature. In 2016, we launched end-to-end encryption. That means that all messages that you send and receive from other people are end-to-end encrypted by default. We use the Signal protocol for doing end-to-end encryption. What's special about end-to-end encryption as opposed to, let's say, transport level encryption like SSL is that end-to-end encryption and decryption only happens on the clients, which means that the server never sees the plaintext or the content of your messages. Here's an overview of how end-to-end encryption works at WhatsApp. We can see that all the client and server, so Alice is talking to Bob in this example, all the client and server interactions are encrypted with transport encryption, which is usually the case for a lot of applications today. However, at WhatsApp, the clients also do end-to-end encryption and decryption, respectively. So the server will never see that little purple bubble, which is a message. Instead, it sees the end-to-end encrypted message, and it helps deliver that to the other client, and only the clients are able to see the content of the message. Here's a very high-level idea of end-to-end encryption, or how it could work. So let's say Alice and Bob register for WhatsApp. They each generate a public and private key pair. They both go and upload this key to the WhatsApp server. Then at a later point in time, Alice wants to talk to Bob, so it asks the WhatsApp server for Bob's public key. It somehow uses that public key to encrypt a message saying, hey, Bob, uploads the message to the server delivers it to Bob, then Bob can later use his private key to decrypt the message. In reality, though, the Signal protocol that we use is much more complicated than that. There's a lot of keys here, and they keep changing and rotating in different directions, as you can see here. We won't dive into all these details. Essentially, a lot of these complications come from the fact that we want to support many properties, such as forward secrecy or the protocol working well in an asynchronous fashion. If you want to learn more about it, though, there's a link at the end of our presentation that goes into more detail about this. Another important principle for when we build products on WhatsApp is data minimization. Essentially, data minimization says that we should use the least amount of data to make our product work. Usually, a lot of extra work is required to do this. For example, we have to ask ourselves the question of, do we really need this data field? Can we make our product work without storing or ideally seeing or accessing this field at all? We talked about this theme of client being the server, which means that client does a lot of the heavy lifting. The server is a facilitator, which facilitates things that the clients can't just do by themselves. For example, routing and delivering messages when a participant is offline, or integrity. But in general, we don't trust the server when it comes to, especially when it comes to security and privacy guarantees. So we want to think in terms of minimizing server capabilities. Let's discuss a little bit about what that means. So we think in terms of what capabilities does the server have, and how can we minimize relying on the server for privacy guarantees. Essentially, there's this notion of a policy and a capability. A policy is just some internal rule that a product or company says. For example, a messenger that is not end-to-end encrypted can say, well, we don't read your messages. But you kind of have to take their word for that. They have the capability. They could have the capability of reading your message. They just say they don't do it. On the other hand, the capability is what a company or product is capable of achieving if they wanted to. When it comes to privacy, we want to rely on capabilities. So for example, we can't read your messages, and this is much more powerful than a policy of not reading your messages. There are some other requirements when it comes to building products on WhatsApp. For example, we have a pretty high quality bar. Our product needs to work well with a diverse set of clients, which means devices, and also a diverse set of network conditions. Not everyone has the latest iPhone or Android phone, and they might not be on 4G or Wi-Fi. So our product should work well with low-end devices and on networks that might not be very high-quality networks. Our user base is pretty large, which means we can't just build products about tech-savvy users. For example, in WhatsApp, you don't need a username and password to register, and end-to-end encryption is on when you talk to other people by default on the platform. We also care about integrity, so we want to avoid spam, scams, and other safety issues in our platform. Let's dive a little bit into how we did end-to-end encrypted backups. So there are some use cases where the user needs to be able to restore the state, which means that the messages from one device to another. This could be when you get a new device, you get a new phone maybe, or you lose your previous phone and you want to set up WhatsApp from scratch on your new phone. It's especially tricky when your old device is not available. As we mentioned before, this principle of client being the server, WhatsApp only stores your messages on your device, on your phone. So we need to think about how we recover the state into the new phone. One challenge here is that can we somehow maintain our end-to-end encryption guarantees with backups? So last year, WhatsApp became the first major messaging app to support end-to-end encrypted backups. Let's see how we did that. So one simple way of doing encrypted backups or end-to-end encrypted backups is, well, you can generate an encryption key on the client, then the phone can encrypt the backup with that key, and then it uploads it to Google Drive or iCloud. And then we ask the user, well, if you want to restore from the backup, you have to remember this long encryption key. However, as we saw before, this doesn't quite scale for all the users, but we'll dive into that later. So essentially, we were able to leverage HSMs, which are specialized hardware, to help the user securely store this encryption key. And HSMs also are tamper-proof, which means that WhatsApp can't access the material inside the HSM easily, and they prevent brute force attacks as well. So here's an overview of how end-to-end encrypted backups could work with the user managing their own encryption key. So this is pretty straightforward, right? The client can encrypt the backup, upload the encrypted backup, then the user has to manage their own key. And here's how we're able to leverage HSMs to make this flow a little bit more user-friendly. So as before, the clients generate an encryption key and use that key to then go and encrypt the backup that's uploaded to the cloud. However, we also ask the user, if they want, to create a password Now, this password is then used to securely store the encryption key inside the HSM. So the HSM has a secure copy of this encryption key now, which is protected by your password. And the HSM has the ability to verify your password without actually storing your password or the plaintext encryption key. So the details here are pretty complicated. We use the opaque protocol, and we won't go into all those details. But essentially, this provides a server a way to securely store the backup encryption key protected by a user password without knowing the user's password. So the theme here is that we want to limit the capability that the server has. So the server is facilitating the user restoring the backup key, but doesn't know this backup key, and also cannot, even if it wanted to, cannot brute force the backup key. And essentially, we'll leverage HSMs to limit the server's capabilities. There is some future work we could do here. For example, can we make this even more user-friendly? So we saw that with end-to-end encrypted backups with HSMs in WhatsApp, the user doesn't have to remember the whole encryption key. They could just remember this password. However, that's still a password they have to remember. Not everyone wants to do that. So how can we make this more user-friendly? Some ideas here could be, well, could we somehow leverage operating system key stores, or even maybe split the key and use some sort of social key recovery? These are still very exploratory ideas right now. Let's talk a little bit about privacy tokens. So sometimes it's useful to have some mechanism on the server side to be able to verify some sort of relationships or interaction between users. For example, you could imagine a setting where the users can say, only people I've messaged can see my presence, or only Alice and Bob can see my profile picture. However, we don't store who everyone is talking to on WhatsApp, and we really don't want to do that as a privacy guarantee. So how can we achieve such product use cases while maintaining our privacy bar? Here is where privacy tokens come in. So privacy tokens are essentially a platform that allows users to distribute these tokens to other peers. And later, the server has the ability to verify that the peer possesses the right token. So let's see how that could work. So here's an example, just a theoretical example of Alice wants to maybe protect her profile picture and only allows, for example, Bob or a few people to see the profile picture. So Alice will generate a profile picture token, upload it to the WhatsApp server, and then Alice can securely send this token to her trusted peers like Bob in this example. Notice that Alice already has a way to communicate via Bob in a secure fashion, which is our end-to-end encrypted channel. Later on, when Bob wants to view Alice's picture and wants to ask the server for Alice's picture, he can present this token that Alice securely sent to him. The server can verify that Bob has the right token and then choose to return the picture to Bob. So the server might not know, or the server doesn't know in this case, who the set of users is that Alice shared this profile picture permission or profile picture token with, but can verify that the user possesses the right token to be able to view Alice's profile picture. So essentially, the result is that this is a way for the client to present a proof to the server in runtime, and the server can verify certain relationship or interaction information with continuing to not store this interaction information, which is very sensitive for privacy. So essentially, privacy tokens can enable complex privacy or integrity checks in a privacy-safe way. So this looks relatively straightforward, but there's still a bunch of challenges under the hood. For example, we said before that we care a lot about quality and reliability. Well, privacy tokens will increase payload sizes. We have to essentially write extra bytes in the wire. This impacts reliability. We have to think of that. Multi-device presents a challenge here. For example, a user can have multiple devices. We need to figure out how we sync tokens across all of these devices and handle many of the edge cases that arise. As well as tokens could be lost. There could be bugs somewhere that the token is dropped. User can lose their phone. And we have to think from the engineering as well as the product side, how we treat those edge cases. So we're still very early with privacy tokens, and there is a lot more work to do in this area. Here is some examples. We could use privacy tokens to remove more data that's stored on the server. We could use privacy tokens to enable new functionality in a private way in WhatsApp, as we saw before, with like continuing storing this interaction or relationship information. And we could use privacy tokens to prevent spam or even scraping. Let's talk a little bit about security. So security is really the foundation that enables us to build private products. A lot of what we discussed so far falls apart if our systems are insecure. And this idea that the client is the server means that the attackers will focus more on the client because that's where the data is. So that's how we sort of prioritize security in WhatsApp. Some challenges in the area are memory safety, for example. Many zero-day attacks happen due to memory safety issues. There's a lot of work that's going on into this area in WhatsApp. For example, fuzzing, static analysis, different hardening techniques, having safer abstractions, and training engineers, while also piloting memory-safe languages like Rust. We have this theme as well, like how can we think of client as the adversary? So because messages and things like authentication keys and whatnot are stored on the clients, we have to think of how much damage can an attacker do with some client-side access. This could include examples like friends or family trying to sort of temporarily get your phone to do something or to try and read some data, or even malware may be running on your device that could try to access data within WhatsApp. So overall, here is some areas of future work that we're thinking about. We really think that the privacy frontier is shifting more towards metadata, that is, relationships and interactions and profile data for the user. End-to-end encryption enables us to make sure the data is secure. However, metadata is also really important, and we have to think about it. Some areas to explore here could be using privacy tokens across more use cases, removing or encrypting more user data. So we have some data on the server, we're looking into ways of like how can we remove it or de-identify it or encrypt it. Or maybe also even use de-identified connections. These are essentially de-identified or not authenticated connections that allow the clients to talk to the server in an unauthenticated way. So as we saw, engineering for privacy at scale is pretty challenging. We need to think of reliability, visibility, and integrity. There's a lot that goes on into making the product private and simple. Here's some references for a few of the topics that we discussed. And as always, we're hiring. So if this sounds interesting to you, please reach out. Thank you.